what we have here is our next lesson. And we looked at these examples last time, I believe. But let's go through them again. All right, we have 81 to the power of 1/2. Now, as you recall, there's a couple of rules we need to pay attention to here. One is an old one, and the top one is the new one since we've been using. Okay, this is a fractional rule. So when we have a fraction as an exponent, the numerator and the denominator play a different function. The denominator becomes the index for the radical, and then the x, the numerator, can appear either on the inside or the outside, depending on where it helps you out. For the most part, these are the ones that we're going to do, because if we do this, blow this thing up first by taking the exponent, it'll be a real big number, and then you have to bring it down. This right here, when you take the root, makes it small, and then when you raise it to that power, we'll be able to take that root. There's one case where this might work, and it'll be towards the end. And just remember the same rule we've had before, that a negative exponent means take the reciprocal. Take the reciprocal. All right, so let's go back over here. All right, so 1/2, the exponent, fraction, the denominator is 2, so that means we have a square root. The square root is the one without anything crooked. It means that there are 2 inside of there. So the square root of 81 is 9. So this one's pretty cut and dry. Any questions on that? The denominator tells you what root to take. Now, example 2, it's a 16 to the negative 5/4. So it's negative, so we have to take the reciprocal, or that's always the best thing to do first, in my opinion. There might be another way around it, but I would always suggest taking that reciprocal first. All right, so we use up the negative by taking the reciprocal, so 16/1 becomes 1/16 to the 5/4. All right, now we're going to use the denominator, the quarter, for a 4th root of that base of 16. All right, and then the 5 goes on the outside. Technically, we could have put the 16 to the 5th power on the inside, but that's going to be a really, really, really huge number. I would rather not go that direction, so that's why I want to go ahead and take the 4th root of 16 first. So 4th root of 16 is 2. 2 times 2 times 2 times 2 is 16. That's why the 4th root of 16 is 2. Then we raise it to the 5th power. So that means 2 times 2 times 2 times 2 times 2, or 16 times 2, which is 1/32. All right. Questions? Okay, so let's go on now to these problems here. The first couple of ones are going to be more or less following example 1. So 9 to the 1/2 power. So what kind of root are we going to use here?
Square root
What's the
of
denominator? It's a
2.
square root. Good. You put it over here. We got plenty of room for this. So that's the square root of 9,
Ends up being 3.
which is 3. Okay. All right. Now realize there's a difference between 2 and 3 here. So we got to make sure we understand that. We talked a little bit about this. I think it's in chapter 2. If whatever the exponent is touching is the base. So in this case, the 1/2 is only touching the 16. If we wanted to include the negative sign, we have to do what's done here, which is use parentheses to mean that it's going to be more than just the number that's touching there. So the parentheses opening up gives us a negative 49 to the 1/2 power. So keep that in mind. Essentially what number 2 is saying is we're taking the negative square root of 16. So this one's another square root, and it's going to be negative. All right, look at that and make sure you.
Oh, it's negative 4. It's the answer for number 2, negative 4.
-4, right?
Yeah.
All right, now, what's going to happen with this one here? This is another square root. All we got is just a 1 with a 2 in the denominator, so
The negative 49 is going to be inside of the square, right?
it's going to be what?
On the inside.
Yeah, that's correct. Now, here's where we have to think a little bit because it's going to be easy to jump to a conclusion here.
There's no square root that's negative.
Yeah, that's the issue because a square root means something that multiplied by itself gets us to that inside. All right. So there's no way, with what we know so far at least, to multiply a number by itself and get a -49. You can try it if you wanted to. First of all, 7 squared is 7 times 7, which is equal to 49. And then if you take -7 squared, that's going to be -7 times -7, which is also 49. So one thing that we can rely on is the square root of any real number. I'm sorry, the square of any real number is going to be positive. Now, here, the key word here is real number. Now, remember back in the first chapter where we talked about the different kinds of numbering? You started out with the bottom, you have natural numbers, which are the counting numbers. Then you go to whole numbers, which include 0. And then you go to positive and negative, which are integers. And then you go on to rational numbers, which are numbers that can be expressed as a fraction, which includes all those numbers at the bottom because even a whole number can be expressed as a fraction by putting it over 1. Now, as we work our way up, we've got the numbers that we're talking about in 7.2, which was something like square root of 2 or square root of 3, which cannot be expressed as a fraction because they're repeating decimals. All right, so we're kind of at the top of the food chain, and in the end of this chapter, we're going to find out what this is called. But for right now, we're just going to say not a real number. All right, not a real number, and that doesn't mean it's those terms mean slightly something different. They would in kind of common language, like real means that it exists, and but there's a set of numbers we're going to talk about in 10.7 called complex numbers, and we'll find out that there is a way to evaluate this. Now, this one here, this 27 is the base. So this, though, is not inside. The negative is not inside, so we're just going to write it as, and that's supposed to be a 3.
It's a -3.
And that's going to be -3. Good. So 3 times 3 times 3 is 27. And then the negative sign was on the outside, making sure that this was going to be negative. Okay, so let's move on a little bit. Well, here's one more that's got only a 1 in the denominator, so we don't have to do too much here, but the parentheses mean that all of those things are inside the root of 3. So we're going to put everything underneath there, and that's another third root. So we got a 125 x to the 15. And I had somebody in my morning class, another teacher, come to visit, and she had informed me that the official calculator, the one that looks like this, here it is, the one that's the official calculator for the class, will actually do what I'm trying to show you on here. So you might take advantage of that because you're free to use that calculator on the exams. Let's see. So my way of doing it is just I write these down and then refer back to them. And so the thing we need to be looking for is cube root of 125, which is the top one here, and that's 5. All right, we can even write it like this if we want to, and then play the same game for the numbers and the variables. So 3 goes into 5 into the third power there, meaning that that's 1 power of 5. And 3 into 15 goes 5 times. All right, makes sense?
Yeah.
I got on here late and I had a question about number 3.
Okay, go shoot.
Why is it negative 49?
Not a real number?
Yeah, why it wouldn't be negative 7?
Okay, look up here at the top. Negative 7 squared is what? Negative 7 times negative 7
7. Yeah.
is 49. Any number that's squared, any real number that's squared, is going to always be positive. Okay? Negative, because there's 2 negatives here. Negative times negative is a positive 49. So find me the number, the real number, that you can multiply times itself and get negative 49. I'm going to wait here until you find that number for me. I'm going to wait a long time because I'll just tell you, hint, there are no numbers that you can square and get a negative value. No real numbers.
Okay. Okay.
So that's how it works. Now, in section 10.7, I believe it is, we're going to learn about complex numbers. So we're going to be able to evaluate this further then, but not now. So that's kind of what it amounts to. Is there's no way to multiply a number by itself, positive or negative, and get a positive real number. So that's why we're saying for right now, it's not a real number. That does not mean that it does not exist, because it does. It's just that it's not a real number. Because remember,
Okay, thank you.
real numbers are the highest form of numbers we know about so far, and we're going to learn about complex numbers at the end of chapter 11. I'm sorry, 7. All right, so the next ones are all going to have numerator and denominator. So this is a third root down there in the bottom, and the whole thing is inside the third root. The negative and the 64. Now, this is a bit different than this one because it's it's an odd root. You got 3 times you're going to multiply the same number, and there are 3 negative signs, so it's possible to have that negative inside for an odd root like this for third root. So we can go ahead on this one because I think we even talked about it last time. The cube root of negative 64 is negative 4. And then when we take negative 4 and raise it to the 4th power,
Negative 256.
it's not negative because you got an even number right there.
Oh, I'm sorry, 256.
So it'll be 256 positive.
Yeah, because it's a negative.
Because if you take negative 4 times negative 4, you got 16 positive. The other 2 4s also giving it a positive 16. You multiply positive 16 times positive 16, you get positive 256. All right. So So 7, the base is only the 9. It does not include the negative sign, so that's why we got to make a distinction between 2 and 3. So this is going to be negative, and it's the square root. All right, you don't need to put the 2 there, but I'm just kind of showing you. And then this whole thing is going to be cubed. And again, the negative sign is not part of the base. The 9 is the only thing that's in the base. So that's square root of 9 is 3, right? And then the negative sign just comes along for the ride. So this is negative 27, right?
Yeah.
All right, I'm going to go this direction to, because we're probably going to need all the space we can get. Now this is, the denominator is cube, is a 3, so it's a cube root. And it's got a fraction in there, okay? It's got 8 and 64. And the numerator is squared. So if you remember the way that you handle fractions is you just put 1 over the numerator and 1 over the denominator. If that makes it clearer to you, you use that in order to evaluate. And then we're going to square. So the cube root of 8 is 2. The cube root of 64 is 4. And that's all squared. Now, it's probably going to be easier if we simplify this now. 2/4 is 1/2. And when you square it, it's 1/4. 1 times 1 is 1. 2 times 2 is 4. Okay? Let me know if you got any questions, because we got plenty of time. Okay, so
Professor Cruz,
mm,
just for that last one, because with 8 and 64, that can already be simplified down to 1/8. You pretty much end up at the same answer. So does it matter if you do that?
no, what are you talking about? Where
Yeah,
here
for
or
the 8/64th. Because if you minimize 8 over 64, that ends up being 1/8, correct?
yeah, you're right. You're right. I mean, let's see. Yeah, and then 1,
And then the 1 goes
and then
into,
it would be, and then the 8 would be 2.
yeah,
You're right. You're right.
yeah.
Yeah, I didn't think about that, but that you can simplify it up there as long as the fraction is fully inside that same radical. Yeah, you can do that.
Okay.
I had noticed that. I probably would have made it a little bit shorter if I'd have done that.
Yeah, I was just asking because I ended up with the same answer as you, but I went about it the other way.
Yeah, that's fine. Yeah, because in here, You can just 80 goes into 8 one time and into 64 8 times. And then the cube root of 1 is, of course, 1, and the cube root of 8 is 2. All right, now we're getting into some negative ones here. And remember, negative means take the reciprocal. All right, that's the only meaning of negative exponents. All right. So this is negative. So what we're going to do first is take the reciprocal. And when we do that, that takes care of the negative sign. So now we can just go ahead just the way we were before. That's a 1/2. So that's going to be 1 over the square root of 25. Okay? Does that look good? Check it for me.
Yeah, that's what I got.
Okay, we got another negative one. It's going to be a cube root. But first we take our reciprocal. And it's going to be brought up to the power of 2/3. Positive now because we took so let's see, then that's going to mean 1 over cube root of 8 all squared. So the cube root of 8 is 2, and then squared is 1/4. Seems strange to have 2 1/4s, so check it for me.
That's what I got.
All right, so we got to take the reciprocal. We got another reciprocal. We got because we got another negative one. And so we got 1 over 36 And that's to the third power because the numerator is 3 and the denominator is 2. So 1 over square root of 36 is 6. And cubed, I think that's 216, right?
Yeah, 216.
All right. I'm going to go over on the other board and I'm going to write another. This one is kind of strange. I want to find one that's a little bit, I want to make up one that's a little bit better. I want to turn them upside down, those numbers. 7/3, but it's still going to be a negative. All right. So you can do this with even with variables. This other one that's on that sheet, you can do with it. You can work it, but it's nothing really happens. So I'll show you what we got here. We're going to take 1 over to get rid of our exponent. I'm sorry, a negative sign in the exponent. And then what we got here, the denominator is 3, so that means I'll tell you what, let me back off one step. Instead of doing what I was going to do, put it on the outside like we did with the other ones. What was that thing? It must be back over here. Oh, oh no, it's right there on top. Just, yeah. See how I told you that you can put it on the inside or the outside, whichever helps you? Well, this one, if you put it on the inside, it's going to help us a little bit more because these are not numbers. You can't really evaluate x to the 7th since we don't know what it is, or the cube root of x because we don't know what it is. All right, now we can play the thing that I showed you about taking the index and dividing it into that exponent, and that goes twice, right? 3 goes into 7 twice, so you got an x to the squared that comes out, but you got 1 that stays in. Oh, maybe that's kind of hard to see. Let me rewrite it. So that would be the simplified form of it right there. That's all you can do. On this one over here, why I thought this one was kind of silly. I don't know why, because these problems, they probably come from my math lab. And those things are algorithmically generated, and probably somebody doesn't check every one of them to see whether it's a good problem. Not that it's bad, it's just that nothing exciting happens that proves a point. So what happens here is, all right, so then this would be the 7th root of x to the 3rd. And nothing can happen there because the index is larger than the power there. So that's all you can do. So I just wanted to make up one where it actually changed a little bit.
Professor Cruz.
Mhm.
For number 12, it wouldn't be a 7, correction, a 1 over that 7x3.
Well, we did it here. Oops, yeah, you're right. Sorry. Yeah, I just forgot to put it. I was trying to write small and I ended up. Okay, so that's all we got on this. Let's so any more questions on any of these before we move on? All right. Let's see. So now we're going to move on to operations with radicals. Now, I'm sure most people remember that when we were dealing with variables, we had something called like terms. In other words, if you had 2x plus 5x, that's 2 plus 5x. You add, if the variables are the same, you just add up the numbers in front of them. It doesn't always have to be positive. They can be positive, negative, both negative. All right. Well, with these radicals, pretty much the same thing can happen as far as adding them and subtracting them, because if they're alike, in other words, same root, same value inside of the root as well, then we can add and subtract them. Okay. So look at that first one. All right, we've got the square root of 12 and the square root of 75. There's nothing alike about those two things. 12 and 75, they're different roots, so we cannot put these together as they stand. So what we're going to do is we're going to use what we learned in 10.3, which was breaking down a radical that was not going to be a perfect square by taking out any perfect squares that existed, and then that would be considered simplification. All right. So what we got here on this first one is 12 is 4 times 3. 75 is 25 times 3. Okay. Now, sometimes when you have a small one like this, that's a good place to start because there's obviously only one perfect square inside of there, inside of 12, and it's 4. And then you can use the number that comes out, provided that you've simplified it far enough. All right, this number should not have any more perfect squares contained within it. So 3, that factor that goes with 4 to make 12, we can divide that into 75 and see that we got 25, which is another perfect square. So 75 can be written as 25 times 3. All right, so now we break it apart into 2 separate radicals. Square root of 4 times square root of 3 plus square root of 25 times square root of 3. And then these two are multiplied, so square root of 4 becomes 2. Bring that down, so that's 2 square roots of 3, or 2 times square roots of 3. Plus 25 times the square root of 3. Square root of 25 is 5 square roots of 3. So now these match. We got 2 square roots of 3 plus 5 square roots of 3. We've got apples and apples. We got 2 boxes of apples, and then 5 boxes of apples. We put it together, we got 7 of them. They're the same unit now, just like terms in a sense. So 2 plus 5 is 7. All right. I'll tell you what, let's take a break a little bit early here. I need to get some air, and then we'll come back, and because we need to get through this at least. This is for next time, right? So I don't want to go too far. So just keep looking if you got any questions. All right, so we got 4 square roots of 3 plus 13 square roots of 3. Since they're both the same, we can just add the numbers in front, the 4 and the 13. So that's 17 square roots of 3. All right, does that make sense?
Yeah.
Okay. Now, the next one, matter of fact, the whole first row are all ones that already have a like radical. See this? We got square root of 2 and square root of 2. So 3 minus 5, I'm sorry, 3 minus 8 is negative 5 square roots of 2. Does that look good?
Yes, I got.
Now this next one, 3, let me just kind of show you. I'm going to give you some of these to work on your own, but all right. There, we're not including just the root, but also the x. So this is negative 8 minus 12, and the like part is the x square roots of 3. So that variable in front, well, it's acting like a variable. So that means we can add and subtract those as well, because it's x square roots of 3 is the like term. All right. All right, you see that? That's the part that's the like term now. It includes the radical, square root of 3, but there's also an x in the front. All right, again, these are not alike, but what can we do to reduce those? Are there any perfect squares inside of 32?
16 times 2.
Yeah, I was going to go back over here. I think it's this one. See, 16 is the largest one in there. There's no 32, there's 36, there's 25, but 16 is the only one that allows us to break it down. So this is 16 times 2. And this is 36 times 2. Now, as I had said previously, it's supposed to be a multiplication there and there. Once you get one broken down, and I would recommend starting with the smallest one, once you find out what that other factor is, you can use that to divide into the other one, because this is going to be the one that stays in there. So 2 into 72 goes 36, and 36 times 2 is 72. So taking the long like until we understand the process. Okay, so square root of 16 is 4. So now we got 4 minus 6 square root of 2, which is what? Negative 2.
Square root of 2.
Mm-hmm. All right. Excuse me. I'm going to go over to my math lab and pull some things out for y'all to work on. Oh, and I was going to do something here. I'm thinking about it. Remember, the final exam is proctored on that Proctor U review thing. So make sure you got that working. I'm going to put it back up there until the last day of class, because you don't really want to go into that cold, because just warning now, there's no time at the end of the semester for somebody that forgets to take the exam or they had technical problems the night of the exam. I'm going to have it up there for 3 days, so just remember that. So I'm putting that Proctor U review check again there, because I can go in there and see whether you've done that kind of thing or not. Because, like I said, is at the end of the semester, I'm under the gun, practically somebody holding a gun to me and want those grades turned down. I got to get them done by the end of that first week, by that Friday, which is like Friday the 7th. So let me bring that all up about just so you can see where we're at. We don't have that much time to go. All right. So here's one more week here, 19th and the 21st, 26th and the 28th. The last test is taken here by this time. Now, the problem is, which I don't like, but I can't really figure out a way to test it unless we speed up a little bit, is that when we come back on this day, which is the last day of class, the third day, that only gives us that 1 day to review for the exam. Now, in this class, I kind of think that'll be plenty, because we got double, we got 2 hours and something with a normal class where it just meets an hour, a little over an hour. It's not really enough time. So that may well work out all right for this class. I got a Tuesday, Thursday class, which I'm really more worried about. So just look at that. Like in 2 weeks, we're essentially done, except for the exam. And that exam, probably what I'll do is I'll have it third, fourth, and fifth. I might be able to do it on the 6th, because like I said, I got a deadline on Friday to get grades done. All right. So make sure you understand that. If you, like I said, if for some reason you still haven't got that Proctor U working, make sure you got it working, because I put that little Proctor review quiz thing out there. It's solely to make sure you got your system working, because you cannot get through this class without that proctored exam. All right. So again, now this one was one that we just worked up there, the two numbers, 12 and 75. So we know what to do on that one. But they're not the same, so we got to go ahead.
So just be open the 3rd through the 5th, right?
And then the 3 goes in 75 25 times. All right, see there, we got the one that are going to be the same when we finish this. All right, so this one is 4 square root of 4, square root of 3, so that's 2. That's the 2. And that one is 5 square root of 3. So as I said, you can put this in here to see what's going on. 2 minus 5 square roots of 3. Okay, does that make sense? You see any problems with that?
That's what I got.
Okay, usually 2 is a good sign. As long as they did it independently, that's a good sign. All right. Oh, and I was over here looking. I got caught up in that little diatribe about the connect, but I was going to try to find some problems for you folks to work on to after we finish this that you can work on to finish out the class. Let's see, 10, it's 10.4. All right, so on this one, all right, we got, I want to work on the smaller one. That's 4 times 5. And what's different about this one is that we got a number in front. So anything that comes out is going to have to,
Does it get added or
it's
multiplied?
going to be multiplied.
Okay.
Because what this means is it's 3 square roots of 20. So whatever square root of 20 is getting multiplied. So if we can take a perfect square out of there, it's going to multiply that because that's part of what the square root of 20 is. All right, so now we got a good one here because it's 4 times 5. 5 is a prime number. We can't reduce that anymore. So use the 5 into the 45, and that goes 9 times, right?
Yeah.
All right. So let me put in this, break them apart. So see, it's 5 times the square root of 9 times the square root of 5. The square root of 5 is going to stay in there. So that's 5 times 3. Because the square root of 9 is 3. All right, so let's whittle that down. 5 times 3 is 15. Plus 6 square root of 5. So that's 21 square root of 5. Does that look good?
Yeah.
All right. So see if you can take a whack at that next one. That next one should be fairly easy because the square root of 8 breaks down to 4 times 2. And then you can use the 2 into the 50 to give you the other one.
I got 30 square root 2.
All right, let's see. And so we got 4 times 2. So 2 goes into 50 25 times. And then this is 4 times 5. So we got 10 square root of 2 and 20 square root of 2, which is 30 square root of 2. All right, try that next one. Like I said, I'm looking for some problems to show you all that y'all can work. It won't take us maybe 10 minutes to finish the rest of this. And we'll do something to do for the rest of the class. I guess some of the well, that's they got it broken up into
No, I don't hear you. Can anybody else in the class hear me?
Yes, I do. I do hear you.
Did y'all finish number 8 yet?
Yes.
What
Let me
did you get?
see.
I got -8 squared 6.
No, I can't. I got it. Hold on, let me see. I got -7
You got
squared 3. Oh, but he multiplied it by 6. Well, it's because instead of putting it 4 times 6, I multiply it 8 times 3 and 50 times 3. So you multiply it by 6, right?
Yeah, I did it by 6.
Yeah, I think I just have to remake it.
Yeah, so the 24 was 4 times 6, and the 150 was 25 times 6.
Yeah, and like I said, you can use that as a hint when you do the smaller one, and then divide 6 into 150, and if you get back a perfect square, you know you got it. All right. So this is, I'll tell you what, this is 2 square root of 6 minus 2 times 5 square root of 6.
Mhm.
And 2 minus 10 is -8 square root of 6. Is that right?
That's what I got.
All right. All right, now the last one's kind of a mess. It ends up similar to 3. You're going to have an X come out in front. See if you can do this. And I'm trying to.
I think I got the answer for that one.
You do?
Yeah.
All right, let's see if somebody else can come up with it. Like I said, I'm trying to find some more to give y'all to finish out like the last 20 minutes here. All right, so I'm going to start over here. See, that's the square root of 6. 6 can only be broken down into 2 times 3, neither of which are perfect squares. So 6 is the number that I need to deal with. Now, we've got a y cubed in there, and we can take the square root of that and bring one y out. But what's going to happen here is this, in this middle term, there's a y sitting in there that's stuck in there because it's smaller than that index of 2. So even if you can't see it, I'm telling you that what's going to be end up staying inside is the 6 and the y. That's why I'm going to use the 6 to divide into these other ones. All right. So this is going to be 6 times what?
6 times.
6 times 9. Well, 9
And
times
9 is a perfect square, so that's good news. And then there's a y cubed. We'll deal with that next. And 6 into 24, well, that's the one we did over here. That's 4 times.
4 times 6.
And we still got a y in there. Now, if we got any hope of putting these all together, there's going to be a y left in there. And both the first and the last both have one y that's going to stay in there. So that's good news. So this is going to be a square root of 9, and one y is going to come out. Square root of 9 is 3, and one y is going to come out, and one's going to stay in there. Oops, that's going to be a 2. And then a y is going to come out because there's y cubed. So square root of y squared is going to give us a y out front, and then 6y staying in there. All right. Let me switch to a different color here. All right, so here's the part. Well, I can't really do it on that one because I got the y over there, but see, we're not only matching up the 6y, we're matching up the y that's in front of it. But I'll fix that other one in the middle. So this is negative 6 y square roots of 6y. All right, so again, see, that's the part that's alike. So what do we have left? We got negative 6, we got plus 10, and we got a negative 1 square root, let's see, y square root of 6y. So that's a negative 7 plus 10 is negative, it's 3 positive y square roots of 6y. Does that look good?
Yep, that's what I got.
All right.
Same here.
All right. So what I'm going to do is I'm going to see if I can, well, I'm going to see if I can screencast this to you and see if you can see it well enough. All right. Y'all can see that, it looks like. All right. So tell me, are these like terms?
Yes.
They are?
I would
What's
say
like
no
about
because
them?
the second one is what?
Exponent.
The 6th root.
And this is a square
And the
root,
first one is
right?
2, yeah.
So these are unlike. All right. Are these like terms?
Yes.
They're both 5th roots,
No.
and they're both got an a squared times b. They're just in a different order.
A square B, yeah.
All right. Are these alike? X, Y, Z, and
Yes.
4th root. Yeah, they're alike. Okay. Like or unlike?
Like
I guess technically.
What's like about them?
They're both
they both gonna be multiplied. I
What's
mean, the
inside
5
the
gonna
radical on
remind
each one of them? What's
the
inside of the radical?
8x.
Yeah, that part's the same, but the radical part.
I mean, if we multiply 2 times, 2 times 5,
What
then
is the like term? What is the like radical then?
oh,
What is it? What's the like radical? You should be able to tell me that if they're both alike. Which one is alike? Square root
for
of
me,
5 or square root of 10?
the
Are those
square root
both
of 5. I don't. I'm confused.
are they both the same? Let me ask that again. Square root of 5 and square root of 10.
Square root of 5, I guess.
Okay. So you're saying the square root of 5 is like to what? Where's the other one like it?
I mean, in my mind, I'm seeing it like this. For example, what you did with that 6y, you just take it and it remains the
Well,
same.
but that's only part of it. Okay. That part is the same. Yeah. But I'm talking about the radical part.
Oh yeah, I don't know.
See, that's a square root of 5 and this is a square root of
10. I mean, you're right. So they're unlike.
All right. So see if you can work this one out. This one should be pretty easy. Wish I could write on here.
11 and square root of 5.
Yeah, 8 plus 3 is
Well,
11.
That's, yeah, square root.
Thirteen the square root of 3.
Okay.
11 the square root of x.
Yeah, you got 12 minus 1. What about this one?
6 the square root
Yeah,
of
7 take away 1.
x.
8 square roots of 3 and 3 square roots of 3.
It'll be 7. 9. Oh yeah, because they're adding 9.
8 plus 1. All right, these ones got to be simplified. So what happens with that one? That's more like what we've been doing here.
So we have to break down the 125.
Yes, yes. and that x cubed.
Yeah. So that would be 5 times 25.
Uh, yeah, 5 times 25 times 5, right?
Four x 5x plus. Is it 34x 5x squared 5x?
Yeah, 34 x square root of 5x. Nine times 3 minus 2, 9 times 2, and then, oops. Boy, am I getting tired, or is this one just not going to go completely together? So did you need?
See, that's what I was just about to ask. Because if they all don't have the same matching, what is it, whatever, then it still ends up just being a problem, right?
Well, I mean, that's I've seen them like that before. It's just that we didn't have anything like that on the worksheet.
All right.
But that's not unusual. They just going over basics in the worksheet. So 6 square root of 10. So 9 and 4 is 13. Not x. What have I got? X in there. It's 2. So we got to think cube roots now, like 8, 27. 27 is too big, so look for 8 as a factor of 24. And then use the remainder thing, the one that stays in there, as a hint for 192, because the 192 is large. All right, so this is 24 is 4 times, 8 times 3. So it looks like 3x is going to stay in there. So let's multiply 3 into 192. What do we get?
It's 64.
64, so that's a good one because that's a perfect square. All right, so we got cube root of 8, which is 2, and then 3x stays inside. We got the cube root of 64, which is 4, takes on that negative sign, and then cube root of 3x. So that's 2 minus 4.
Thank you.
How does that look?
You work a lot faster than me.
Well, you was working pretty good before. I was surprised.
It's when it gets to the larger numbers.
Well, yeah. Well, I was trying to tell you, the trick here is, okay, find your perfect square in 24. There's only one of them that's going to work. It's 4 times 6. Then use the, I'm sorry, 8 times 3. It's cubic root. So use your 3 into the 192. Like I said, use those hints. Let's just do one more. Let's just see. I don't know if I want to do it. What should we do? This one? Or this one? Try this one. This is not too bad, actually. I'm working them on that little board. You just can't see it because it's on my. It's not on the share. But I'll let you see them when we're done here.
Is that 14 square root 5?
Let's see. Now you're working too fast here. All right. So 4 times the square root of 25 is 5. That's going to be 20. The only square root is going to left is going to be the 5, so that's 20
minus 16.
Minus 16. So that's 4 plus square root of 5. Right?
Yeah, that's
Nothing
what I got.
happened with the 5. The square root of 5 just stayed on its own. The other two ended up being
Oh, okay, so just real quick. So when you end up to where you can't add them together, then it's 4 plus square root 5?
Yeah, because they're different terms. 4 is whole numbers.
Okay.
So here's the work if you want to see it here that I was doing on all the ones that weren't broken down. In other words, we have to find square root, find the roots. I don't know. Are y'all as tired as I am? I don't know why this class is.
It's the rain.
I'm talking about for the semester. I don't know.
It's late at night.
I'm just wondering if I'm gonna make it to the end of the semester. I feel like I'm gonna just drop over.
You only have a few more weeks.
I know, I just never been this tired before. You'd think that just working in front of computers and all that would not be as much work as jumping around in front of a classroom. All right, so have as good a weekend as you can. Monday we will continue our journey. So, all right. Yeah, next time we got the multiplication and division, and then we can use multiplication. I'm sorry, it's just multiplication. Rationalizing the denominator is sort of like dividing. You don't really have a strict operation for dividing with rational numbers. But this thing called rationalizing the denominator essentially does the same thing. So remember how division is the multiplication by the reciprocal. It's sort of like that. So we just need to figure out how to multiply. Then we'll apply it to
Mr. Cruz,
rationalizing the denominator.
for the final, we still have till midnight to do that too, right?
Well, if I can, it depends when you say.
You said it's open
what
from.
midnight you're talking about.
You said it's open from the 3rd to the 5th, huh?
Yeah, and I mean I'll leave it open tonight, because like I said, I like to be able to get up in the morning and start working everything out.
Okay, all right.